Ninth problem. F of x is equal to 1 by mod x plus 2. F of x equal to 1 by mod x plus 2. So f of x belongs to capital R. Mod x plus 2 is not equal to 0. So when it is mod function equal to 0, it is a x equal to 0. So x plus 2 is not equal to 0. From this x is not equal to minus 2. So all the real numbers except minus 2. So x is belongs to r minus minus 2. The domain of f is r minus minus 2. The 10th problem, f of x is equal to 1 by mod x minus 2. F of x belongs to capital R. Mod x minus 2 is not equal to 0. So x minus 2 is not equal to 0. So from this x is not equal to 2. So therefore x belongs to R minus 2. So the domain of f is R minus 2. Next, the 11th problem. F of x is equal to 1 by mod x minus x. So f of x is belongs to capital R. Mod x minus x is not equal to 0. That means mod x is not equal to x. So mod x is defined like this: x if x is greater than or equal to 0, minus if x is less than 0. It is 0 for x equal to 0. So mod x is not equal to x means it is equal to minus x. So here when it is happen, x is belongs to, it is less than 0. Less than 0 means x is belongs to from minus infinity to 0. So therefore the domain of f is minus infinity to 0. 12th one, f of x is equal to 1 by mod x plus x. F of x is belongs to capital R. Mod x plus x is not equal to 0. So mod x is not equal to minus x. Minus x means it is greater than 0. X is greater than 0. So that means x is belongs to 0 to infinity. So therefore the domain of f is 0 to infinity. Next bit, the first one, f of x equal to 1 by step x. So here f of x is belongs to capital R. Step x is not equal to 0. When step x equal to 0, it is x is here, it is a 0, 1, 2. So when the step x value becomes 0 for all the values from 0 to 1. So here x is belongs to from closed interval 0 to 1 open interval. So left to close to 0 to right open 1. So therefore the domain of f is closed interval 0 to 1. The second problem, f of x equal to 1 by mod x minus 1. So f of x belongs to R. Step x minus 1 is not equal to 0. So we will get step x is not equal to 1. So we will get step x is belongs to, so x is belongs to, here step x is not equal to 1 means here it is a step x is not equal to 0 means x is not belongs to 0 to 1. So all the real numbers except to 0 comma 1. Here also x is belongs to not equal to 1. 1 means we will get closed interval 1 to 2 open. So it is x does not belongs to. So x is belongs to all the real numbers 1 comma 2. So therefore the domain of f is r minus 1 comma 2. Left to closed 1, right to open 2. So third one, f of x equal to 1 by step x minus 5. So plus 5, f of x is belongs to capital R. So step x plus 5 is not equal to 0. So we will get step x is not equal to minus 5. If step x is not equal to minus 5 means it is the values will be minus 5 to minus 4 up to 4. So x is belongs to closed interval, x is not belongs to minus 5 to minus open. So therefore the domain of it is a x is belongs to r minus 5 comma 4. So the domain of f is r minus 5 comma minus 4. Next, fourth one, f of x equal to 1 by step x square minus 5 into step x plus 6. So f of x is belongs to capital R. Step x square minus 5 into step x plus 6 is not equal to 0. Here we will get step x square minus 3 into step x minus 2 into step x plus 6 is not equal to 0. Step x is common. Step x is common from these two terms. We will get step x minus 3 minus 2 common. We will get step x minus 3 is not equal to 0. So from this we will get in these two terms step x minus 3 is common. We will get step x minus 3 into step x minus 2 is not equal to 0. Step x minus 3 is not equal to 0. Step x minus 2 is not equal to 0. Step x is not equal to 3 and step x is not equal to 2. Step x is not equal to 3 means x is belongs to from 3 to 4 and x is belongs to from 2 to 3. 2 to 3. So here not belongs to. So from this x is not belongs to from 3 to here it is a from here it is 0 1 2 3. Here except all the values 3 and 4 these values. So 4 is included, 3 is not included. So 2 to 3 means 2 and 3 is not, 2 is not included and 3 is included. So what is the combination for this? So x is not belongs to closed interval 3 to 4. So x is belongs to all the real numbers except to minus 3 comma 4. Sorry, 3 comma 4. So that means okay, this is the domain of f is r minus 3 to 4. So that means minus infinity to 3 union 4 to infinity. Well, one mistake here from 2 to 4. So here it is a minus infinity to 2 union 4 to infinity. Next problem, fifth problem, f of x equal to 1 by step x square plus 5 step x plus 6. Here f of x is belongs to capital R. Step x square plus 5 into step x plus 6 is not equal to 0. So this is, we can write it as step x plus 3 into step x plus 2 into step x plus 6 is not equal to 0. So step x is common. We will get step x plus 3 plus 2 common. Step x plus 3 is not equal to 0. So in these two terms, step x plus 3 is common. Step x plus 3 is not equal to 0, or step x plus 2 is not equal to 0. Step x is not equal to minus 3 and step x is not equal to minus 2. So this means x belongs to closed interval minus 3 to minus 2. Here it is not belongs to. So here also not belongs to closed interval minus 2 to minus 1. So this means x is belongs to from minus infinity to minus 3 union closed interval minus 2 to infinity. It means x is belongs to from minus infinity to minus 2 union minus 1 to closed interval minus 1 to infinity. So this means here it is a, so here it is a, we have to take the combination. We have to take the combination. So here it is a from minus 3 minus 2 minus 1 0 1. It is a from minus infinity to minus 3, not included minus 3. Here minus 2 included, from minus 2 to infinity. It is minus infinity to minus 2 and minus 1 to, it is a closed interval, minus 1 included infinity. So here it is a minus 3 is not included. So the combination means this and this. So we will get x is belongs to from minus infinity to minus 3 union minus 1 to infinity. Next, the last model. First problem, f of x equal to 1 by log x. 1 by log x. So for f of x belongs to capital R, log x should not be equal to 0. So log x is not equal to 0. When log x value becomes 0? When it is log 1 is 0. So from this x is not equal to 1. So therefore x is belongs to all the real numbers except 1. So therefore the domain of f is r minus 1. Next, second one, f of x equal to 1 by log x minus 2. So for f of x belongs to capital R, here log x minus 2 is not equal to 0. That means x minus 2 is not equal to 1. So that means x is not equal to 1 plus 2. X is not equal to 3. So all the real numbers, x is belongs to all the real numbers except to 3. The next problem, f of x equal to 1 by log of x square minus 5x plus 7. So f of x is belongs to capital R. Log of x square minus 5x plus 7 is not equal to 1. So from this log function will be equal to 0 when it is inner function should be equal to 1. So log 1 equal to 0 means x square minus 5x plus 7 is not equal to 1. From this x square minus 5x plus 7 minus 1 is not equal to 0. We will get x square minus 5x plus 6 is not equal to 0. X square minus 3x minus 2x plus 6 is not equal to 0. X is common, x minus 3 minus 2 common, x minus 3. So both the terms x minus 3 is common. we will get x minus 3 into x minus 2 is not equal to 0. X minus 3 is not equal to 0 and x minus 2 is not equal to 0. So x is not equal to 3, x is not equal to 2. So therefore x is belongs to all the real numbers except 2 and 3. Therefore the domain of f is r minus 2 comma 3.